Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazid bin Miswan. My student ID is 2019220634 and I'm from J4EM1103F. So today we're gonna do experiment 3, straight beam experiment. Wear mask, appropriate attire and wear gloves to prevent injuries during lab session. So for both steel and brass, there are slightly difference between the experimental reaction force and calculation reaction force. All these differences may due to errors such as instrumental errors and environmental errors. In this case, instrumental error may happen on dynamometer that does not functionally well and read the reaction force wrongly, while the environmental error may happen because the lab area is windy or the bar is vibrating, thus causing the scale to read incorrectly. It is important so that we can locate the critical section for failure based on the shear force diagram and bending moment diagram that show how shear force and bending moment vary along the loading position of the beam, particularly the maximum and minimum values of these quantities. The location of critical section is also important to keep the structure stable and functional. Based on the result, maximum shear stress and maximum bending stress for steel is higher than brass. So steel is stronger than brass because it can receive much more maximum allowable load before it became failure. In addition, steel also made of alloy which contain iron and carbon. Yes, there is difference because if we measure from the bottom of the beam, the shear force will be negative shear. The negative directions are denoted by an internal shear force that causes counterclockwise rotation of the member on which it acts and an internal moment that causes tension or pushing on the upper arm of the member. Now, there is no difference because if we calculate from the bottom of the beam, the value of maximum bending moment and maximum shear stress do not differ because the value of C, distance from neutral axis, is the same between top of the beam and bottom of the beam. Same goes to the Q, which is first moment of area, is also the same between top of the beam and bottom of the beam. There are two types of beam. Firstly, statically determinate beam and statically indeterminate beam. Statically determinate beam is happen when the reaction force can be calculated using equilibrium equation alone. So these are three types of statically determinate beam. While for statically indeterminate beam, it happens if the number of unknowns exceeds the number of equations. So these are type of statically indeterminate beam.